Preparing for a security engineer at Splunk interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a Splunk-based security monitoring architecture for a large enterprise? I would begin by identifying critical telemetry, identity, endpoint, network, cloud, application, and vulnerability data. Universal or heavy forwarders would collect and route events to clustered indexers, while search heads provide distributed searches and dashboards. I would use separate indexes, retention policies, role-based access, encryption, and multi-site clustering for resilience. Data models and CIM normalization would support consistent detections. Finally, I would load test ingestion, search concurrency, and storage growth before production rollout. While answering, cover data sources, forwarders, indexers, search heads, deployment tiers, retention, high availability, access controls, network segmentation, data normalization, and capacity planning for ingestion and search workloads. Question 2. What is the Splunk Common Information Model, and why is it important for security operations? The Common Information Model, or CIM, is Splunk's framework for representing security and operational events with consistent field names and meanings. For example, different firewalls can map source IP, destination IP, action, and user into common fields. That consistency lets enterprise security, correlation searches, and dashboards work across vendors. I would validate mappings with the CIM data model audit, fix missing fields at ingestion, and avoid forcing inaccurate mappings simply to appear compliant. Make sure to cover normalized fields, data models, source types, accelerated searches, cross-source correlation, validation, CIM compliance, and how normalization improves detection portability and analyst efficiency. Question 3. How would you write and optimize an SPL search to detect suspicious PowerShell activity? I would first confirm that endpoint data captures process creation and command line fields. A search could filter for PowerShell executions, encoded commands, download cradles, or suspicious parent processes, then enrich results with user, host, and asset context. I would constrain indexes and time ranges early, use indexed fields and T-stats when the data model supports it, and exclude approved administrative scripts. Before deployment, I would test benign and malicious examples and measure runtime and alert quality. In your answer, discuss precise indexes and source types, relevant process fields, command line indicators, filtering early, T-stats where appropriate, macros, false positive exclusions, time bounds, and testing against known attack data. Question 4. How do you distinguish a true positive from a false positive in a security alert? I treat an alert as a hypothesis, not proof. I examine the initiating user, asset criticality, process lineage, destination reputation, timing, and related authentication or network events. I compare behavior with a known baseline and consult threat intelligence, but I do not rely on reputation alone. If activity is authorized, I document the business reason and tune narrowly. If evidence is malicious, I preserve artifacts, escalate severity, and record the investigative rationale. Be sure to mention alert context, asset and identity risk, baseline behavior, threat intelligence, corroborating events, business context, investigation timelines, analyst feedback, and documented tuning decisions. Question 5. How would you investigate a suspected compromised user account using Splunk? I would build a timeline of successful and failed logins, MFA challenges, source addresses, devices, applications, privilege changes, and sensitive actions. I would compare the account with its normal geography, hours, and peer behavior, then correlate endpoint and cloud activity. I would validate whether travel or VPN use explains anomalies. If compromise is likely, I would recommend session revocation, credential reset, token invalidation, and host isolation while preserving evidence and coordinating with identity responders. Focus on authentication timelines, impossible travel, MFA events, source locations, device posture, privilege changes, cloud activity, peer comparisons, containment, evidence preservation, and communication with identity and incident response teams. Question 6. What is the difference between a correlation search, an alert, and a notable event in Splunk Enterprise Security? A correlation search is the detection logic, usually scheduled or triggered by incoming events. When its conditions are met, it can create a notable event in enterprise security, which is the analyst-facing case signal containing urgency, owner, rule name, and context. An alert is the broader action or notification generated by a search. I would design searches to produce meaningful notables, attach risk scores and adaptive responses, and suppress duplicates without hiding distinct incidents. Explain detection logic, scheduling, triggering, notable creation, risk attribution, adaptive response, suppression, urgency, ownership, and how these components fit into an analyst's investigation workflow. Question 7. How would you reduce alert fatigue in a Splunk security operations environment? I would measure volume, false positive rate, analyst disposition, time to triage, and confirmed incidents by detection. Then I would consolidate duplicate rules, add asset and identity context, use thresholds instead of single event alerts, and apply narrow, documented suppressions. Risk-based alerting can aggregate low-signal behaviors into one higher confidence notable. I would review exceptions regularly because permanent allo lists create blind spots. The goal is fewer, more actionable alerts rather than simply fewer alerts. Discuss precision-first detection design, risk-based alerting, suppression, deduplication, thresholds, asset and identity context, exception management, feedback loops, service-level metrics, and periodic review of detection effectiveness. Question 8. How would you onboard a new security data source into Splunk? I would define the security use cases first, then confirm the vendor format, collection method, volume, latency, and retention needs. I would configure the appropriate technology add-on, validate timestamps, source types, line breaking, field extraction, and host identification. Next, I would map useful fields to CIM and test representative events, including failures and edge cases. I would quantify license and storage impact, create health monitoring, document ownership, and only then enable production detections. Cover source requirements, collection method, parsing, source type, timestamps, field extraction, CIM mapping, licensing impact, data quality, dashboards, detections, retention, and operational ownership. Question 9. How would you troubleshoot missing or delayed security events in Splunk? I would first determine whether the issue affects one source, a source type, an index, or the entire pipeline. I would check the producing system, network connectivity, forwarder queues, deployment configuration, license status, indexer health, and Splunk internal logs. Then I would verify timestamps and search earliest and latest boundaries, since incorrect time parsing can mimic data loss. I would trace a known event end-to-end, identify the failing stage, restore flow, and add preventive monitoring. Mention source health, network paths, forwarder queues, deployment configuration, parsing, indexing, timestamps, license limits, monitoring console, internal logs, search time ranges, and an evidence-driven troubleshooting sequence. Question 10. What is risk-based alerting, and when would you use it in Splunk Enterprise Security? Risk-based alerting assigns risk to entities such as users, hosts, or accounts when individual behaviors occur. Instead of escalating every weak signal, Splunk can accumulate related risk events until a threshold indicates a meaningful attack pattern. I would use it for behaviors like suspicious login, privilege change, and unusual data access that become compelling together. I would retain immediate alerts for high-confidence events, calibrate scores with historical data, and ensure analysts can explain every contributing signal. Explain risk events, cumulative scoring, entities, thresholds, behavior chains, context enrichment, reduced alert volume, calibration, explainability, and situations where immediate high-confidence alerts remain preferable. Question 11. How would you integrate Splunk SOAR into an incident response workflow? I would connect notable events to SOAR playbooks that enrich indicators, gather reputation and ownership data, create tickets, and recommend containment. Low-risk actions, such as enrichment, can be automatic. Disruptive actions like disabling accounts or isolating hosts should require approval until confidence is proven. I would use least privilege service accounts, secure secrets, idempotent steps, timeouts, retries, and complete audit logs. Every playbook would be tested with mocked responses and have rollback guidance. Cover playbooks, triggers, approvals, enrichment, containment actions, connector security, retries, idempotency, auditability, human oversight, rollback, and testing automation safely before production activation. Question 12. How would you investigate possible data exfiltration using Splunk? I would correlate proxy, DNS, firewall, endpoint, cloud, and identity events around the suspected user or host. I would look for unusual transfer volume, rare destinations, new cloud storage services, archive creation, abnormal compression, and activity outside normal working patterns. Data sensitivity and business context matter, so I would validate whether the transfer was approved. I would preserve relevant logs, scope other affected accounts, and coordinate containment without assuming every large transfer is malicious. Discuss user and host context, unusual volume, destinations, protocols, cloud storage, DNS, proxy and endpoint telemetry, sensitive data classification, baselines, containment, and careful interpretation of encrypted traffic. Question 13. How do you use threat intelligence effectively in Splunk detections? Threat intelligence is most useful as context, not an unquestioned verdict. I would ingest indicators with source, confidence, first seen, last seen, expiration, and indicator type, then normalize them for reliable matching. A match against a domain or hash should be enriched with the affected user, host, process, and timing before escalation. I would prioritize corroborated, current intelligence, expire stale indicators, monitor false positives, and measure whether intelligence improves detection outcomes. Mention source reliability, indicator aging, confidence, matching fields, lookups, threat intelligence frameworks, enrichment versus blocking, expiration, false positives, and validation against observed internal behavior. Question 14. How would you secure a Splunk deployment itself? I would treat Splunk as a high-value security system because it contains sensitive telemetry. Controls would include SSO with MFA, least privilege roles, strict index permissions, encrypted management and data transport, protected certificates and secrets, segmented management networks, timely patching, and monitored administrative activity. I would restrict search and export capabilities, secure backups, and review apps and scripts before installation. Finally, I would ingest Splunk internal logs into independent monitoring so tampering remains visible. Be sure to cover RBAC, least privilege, MFA, TLS, certificate management, secure forwarding, secrets, administrative auditing, patching, network segmentation, index permissions, backups, and monitoring Splunk's own logs. Question 15. How would you design a detection for lateral movement across Windows systems? I would combine Windows logon events with process, service, and network telemetry rather than alerting on one remote login. Signals could include unusual administrative logons, new source-to-destination relationships, remote service creation, SMB administrative share use, or PowerShell launched remotely. I would enrich hosts and accounts with criticality and privilege, compare against historical administration patterns, and correlate sequences over time. The detection should map to lateral movement techniques and allow approved management tools through governed exceptions. Cover authentication events, remote services, administrative shares, process creation, source and destination relationships, privileged accounts, baselines, multi-stage correlation, MITRE ATT&CK mapping, and false positive handling. Question 16. How would you validate that a Splunk detection is effective before deploying it? I would define the behavior, required telemetry, expected alert, and acceptable false positive rate before writing the search. Then I would test it against known attack traces, synthetic events, historical benign data, and boundary cases such as missing fields. I would measure detection coverage, precision, latency, and search cost, review the logic with another engineer, and version it in source control. After release, I would monitor outcomes and retune based on analyst evidence. Discuss requirements, representative attack and benign datasets, unit testing, replay, coverage mapping, precision and recall, performance, peer review, version control, and post-deployment monitoring. Question 17. How would you use MITRE ATT&CK to improve a Splunk detection program? I use ATT&CK as a behavior-oriented planning framework. I map each detection to techniques, document the data sources and analytic logic, and identify uncovered high-risk techniques across the attack lifecycle. I prioritize gaps using business impact and adversary relevance, then validate detections through purple team exercises or replayed telemetry. ATT&CK helps communicate coverage and requirements, but a technique checkbox is not proof of effectiveness. Evidence, fidelity, response capability, and continuous testing matter more. Explain technique mapping, telemetry requirements, coverage gaps, detection quality, adversary behavior chains, prioritization by risk, validation exercises, and avoiding the mistake of treating ATT&CK coverage as a complete security guarantee. Question 18. How would you investigate a suspicious cloud activity alert in Splunk? I would start with cloud audit events and reconstruct the identity's API activity, source address, user agent, session issuer, role assumptions, region, resource, and sequence of actions. I would distinguish control plane changes from data plane access and compare behavior with the user's normal workload and approved automation. I would verify whether keys, tokens, or service roles were involved. If suspicious, I would revoke sessions, rotate credentials, preserve cloud evidence, and assess persistence and data access. Mention cloud audit logs, identity context, API actions, roles, regions, resources, session details, baseline behavior, control plane versus data plane activity, containment, and provider-specific limitations. Question 19. Describe a time you improved a security monitoring process or detection. In one environment, analysts received repeated alerts from a noisy authentication rule. I reviewed dispositions, identified that a single event ignored device and privilege context, and redesigned it around risk accumulation, peer baselines, and privileged asset weighting. I partnered with analysts and identity engineers to validate exceptions, replayed historical data, and deployed the change gradually. Alert volume fell substantially while confirmed incidents remained visible. The lesson was to optimize for actionable signal, not impressive detection counts. Make sure to structure the response with situation, technical action, measurable outcome, collaboration, trade-offs, and lessons learned, while demonstrating ownership and customer-focused communication. Question 20. How would you balance detection coverage, search performance, and Splunk licensing costs? I would rank telemetry by detection value, compliance need, investigation value, and volume. High-value fields should be collected reliably, while unnecessary noise can be filtered or routed with care at the source. I would use efficient indexes, bounded searches, indexed fields, T-stats, summaries, and appropriately accelerated data models. Retention tiers can balance cost and investigative access. I would track ingestion, storage, search concurrency, and detection coverage, then make trade-offs transparently with security stakeholders. Discuss data prioritization, filtering at collection, index design, hot and cold retention, summary or accelerated data models, search optimization, ingestion measurement, risk-based prioritization, and preserving high-value evidence. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.